Pat builds a track for his model car out of wood, as in figure D12.6. The track is 5.00 centimeters wide, 1.00 meters high, and 3.00 meters long, and is solid. The runway is cut such that it forms a parabola with the equation y equals, in parentheses, x minus 3 squared. Yep. Locate the horizontal coordinate of the center of gravity of this track.
We're looking for the x center of gravity of this track with a thickness of 5 centimeters. We have an equation for the curve of this graph. In this class, is the x center of gravity going to be different than the x center of mass class? No. So we get an opportunity to review how to figure out the x center of mass. Remind me, what is the equation for the x center of mass? Bailey? This is an object with shape, so this is not going to be the one for particles. This is going to be one with an object with shape. All right, let's help her out, John.
1 over total mass times the integral of r with respect to mass.
I'm going to put x rather than r because we're talking about the x center of mass. If it were the generic equation, we would use an r. Before we could solve this equation, what do we need to figure out first? Please match.
Well, I don't know, like your origin or something.
That's okay. Don't worry. This is review. I need to remind. Well, just that there's a point here. Like this is something that you guys struggle with. That's why we're reviewing it. You're welcome, Meg.
Would we solve for the volumetric mass density?
We're going to use the volumetric mass density when we solve this. Yes, but I need to figure out what we're using it to solve for first. Hamza. The first thing we need to figure out is this mass. Before we can actually use this equation, the first thing we need to do is figure out the mass. What is the equation we're going to use for this mass for an object with shape? It's going to be equal to what? Floor is open. Jenkins.
It's the base times the width, so and then
that would be. But this is we have a curve here, so we can't actually.
Well, I mean, that's like one of the faces, and you have to multiply that.
Actually, we can't quite do it that way, Catherine.
You can take the integral of the function, so.
The integral of dm, right? This is going to get us to the mass. So how are we going to take the integral of dm? Priscilla.
Split it up into infinitesimally thin slices.
We have to split it up into an infinitely large number of infinitely small pieces, dm. This guy right here is dm. Remind me, how wide is dm? Okay. This width right here.
dx.
dx. Remember, this width is dx. It's located a distance x from the y-axis. It has a height y and a thickness t. Remember that has a shape of a rectangle. So as you said, we're going to use the volumetric mass density, which is equal to the mass per unit volume. If we talk about dm, that would be divided by dv. In other words, dm equals rho times dv. What is the volume dv of dm? Tim? The volume of our rectangular box dm.
T times width times height times.
Right, I need specifics. I agree. Length times width times height. What are those letters?
dx times y times t.
T times y times dx. Great. So that is dv, the volume. The thickness times the height times the width. So we have now dm equals rho t y dx. So we can substitute for dm under our integral density times thickness times y times with taking the integral with respect to x. Bill, what now?
Sorry.
We're right here. Tell me what the problem is, or tell me something we can do with that.
Can we pull out the constants?
Okay, what's constant?
Is dx.
dx is what we're taking the integral with respect to. So the question is, what doesn't change depending on which dx we're talking about?
B.
The density, true.
Okay.
What else?
Is that it?
No, that's not it. That's okay. Sierra.
T.
The thickness. The thickness doesn't depend on which one we choose either. So we have now the integral of y dx. Michael, what now?
Just y squared over 2.
Just y squared over 2?
Well-
We take the integral with respect to x as y squared over 2. See the problem?
Yeah.
Okay. Thoughts? Emily?
You can substitute in the equation for y.
We have an equation for y. It seems clear that we can foil. I can remember, is it foil or unfoil? Foil. X squared minus 6x plus 9 divided by 9. So we have the rho times t integral of x squared minus 6x plus 9 divided by 9 with respect to x. What are the limits on this integral? Sarah Jane?
0 to 3.
0 to 3. Note x changes from 0 to 3. Let's see. We could bring out the 9. That'll make life a little bit easier. Rho times t divided by 9. What is the integral of x squared minus 6x plus 9? Meg?
That would be x cubed over 3 minus 6x squared over 2 plus 9x.
9x. From 0 to 3, we then get that the mass is equal to rho times the thickness divided by 9 times the quantity of 3 cubed over 3 minus 6 times 3 squared over 2 plus 9 times 3. Rho times t divided by 9 multiplied by 3 squared, 9 minus 6 times 9 divided by 2, that's 27, bless you, plus 27, so it equals rho times t. Check my math, am I correct there?
Yeah.
Okay. So we get the mass of this object is the density of the object multiplied by the thickness of the object. Great. We don't have the density, but that's okay. We don't have the numbers dependency, right? Class, do you have a numbers dependency?
No.
Eric. So now we have the mass. We can come back to our x center of mass equation, which is 1 over the mass times the integral of x dm. From here, Gary? We're trying to figure out the x center of mass. We just figured out the mass. It's rho times t. We have come back to this equation to solve one. Say again?
Substitute that in for
1 over rho times t, integral of, what are we going to do with x dm?
solve for dm.
Okay, what is dm? This is mildly redundant, so just remember that. He's not seeing it, help him out. Catherine?
Rho times t.
We already went through and figured out that dm is equal to rho t y dx. So we have now rho times t times y, don't want to lose the x, times dx. Rho and t cancel out. We end up with the x center of mass equals the integral of x, y, dx. Hillary.
Substitute x minus 3 squared over that plus.
I'll substitute in this one with the FOIL one, but yes. So we have now x, the integral of x multiplied by the quantity x squared minus 6x plus 9 divided by 9, taking the integral with respect to x. So we now have x cubed minus 6x squared plus 9x. All of this divided by, I'll put 1/9 in the front, that's more fun. The integral with respect to x, again, the limits are the same. X still varies from 0 to 3. Michael, take the integral of x cubed minus 6x squared plus 9x with respect to x.
X to the fourth over 4. Minus 12, minus 6x cubed over 3, so 2 plus 9x squared.
From 0 to 3. So the x center of mass is 1/9 times a quantity 3 to the 4th power over 4 minus, as you said, 2 times 3 squared plus 9 times 3 squared divided by 2. 1/9, 3 to the 4th power.
It's 81/4.
Thank you. 81/4 minus 18 plus.
Your middle term cube.
Thank you. This should be cubed. Thank you. 54, correct?
Yeah.
Okay. What do we get for the x center of mass?
Just 3/4.
0.75